Hey, so this video we're going to be looking at the differentiation and we're going to be looking at the chain rule. So we use the chain rule when we have a function. So I'm going to give ourselves a function here and I'm going to say we have our function of x is equal to, and we're going to take x squared plus 2 and we're going to have all of this, say, to the 3. Now, if this was just an x in here, x to the 3, then we could just use our normal rule. If this was x squared in here, then we do the x squared to the power 3, we apply our normal rule. But we have x squared plus 2. Now you could multiply this out, and from our other video I showed you actually how to multiply out a cubic, but what we're going to do is we're going to apply the chain rule here and we're going to see what we're actually going to do with this. Because this term could be very complicated, it could have any amount of terms inside of it. It could be anything you don't know how to differentiate. So we're going to see what we can do. So if we look here, if we have the derivatives of f of g of x, so our g of x, our function of x of g, so g of our function of x is inside and our f of x is outside. We'll see as we come to it, and we're differentiating this with respect to x, and that is equal to du by dx and by df by du. Now I'll sort of show you what I mean here because it sounds a bit complicated. So what we do is we take what's inside this bracket and we say this is equal to u, which is equal to x squared plus 2. So our u is equal to x squared plus 2. So what we now have is we're now trying to differentiate u cubed. So now we have a function of u, really. Our g now is replaced for u, we have our function of u here. We've also got to have our derivative of u. So our du by dx is equal to, now we differentiate this, we've done this a few times already, we move the power down, so we have 2x and our 2 disappears because it's a constant. Now we can get our derivative of f with respect to u, and we say, right, well, our u here, we move our 3 down, we have our u, and we take 1 off the power, so that goes down to 2. And not forgetting what the u actually is, which is our term here, and now we just put the 2 together. So now we say, we do our du dx by df du, and this is equal to 2x 3 u squared, and then what we do is we multiply 2 and 3 together, so we get 6x, and then we put our u term back in, which is x squared plus 2 all squared there. And that's it. That's how we do our chain rule. So we'll go through another example, nice and easy. So what we'll do is we'll take e and we'll raise our e. I tell you, we'll use the same one here. We'll use x squared plus 2. So we've got e to the x squared plus 2. So we need to find our, we know what our u is now. So our u again is equal to 2, x squared. We'll just put 2 plus x squared, then technically it's the same. And that means we know what our du by dx is, because this is just 2x. And now we need to find our df of du. So if we've got e to the u, well, there's nothing in front of the u, so nothing happens to it. So that is our derivative of u, of e to the u, sorry. And now we just multiply these two together, and we have 2x is equal to 2x e to the u, and we put our u back in, so we have 2x e to the x squared plus 2. And that's another example there. And finally, we'll do one more example, and we'll say if we have sine of, let's say, 4x cubed plus x. Now our u is going to be equal to, you must be getting this by now, x cubed plus x. Our du by dx is then equal to 12x squared plus 1. And when we differentiate sine of u, so our sine of u is going to go to cos u. So what we do is we put all this together and we have our 12x squared plus 1 cos, and we put our u back in, which is 4x cubed plus x. And that's our derivative there. So hopefully from that you'll get what the chain rule is. It's not too hard to follow really. And we're going to be moving on to another rule now. Don't forget, we'll see the last video, next video, or more from my channel. Just click that.